You know, out there in the universe, there are some signals that are supposed to be constants. They're like these perfect cosmic clocks, just ticking away with incredible precision. But what happens when one of those clocks starts to, well, stutter? We're about to dive into a cosmic mystery that starts with exactly that. A weird signal that was hiding an absolutely incredible secret about a planet that frankly just shouldn't even be there. So, to start, we've got to travel a long, long way from home. Picture this. We're heading 7,000 light years away into the constellation Scorpius. I mean, we are really delving deep into a part of space filled with ancient wonders, relics from the very dawn of our galaxy. Right at the heart of this whole mystery is something called a pulsar. And the best way to think of a pulsar is as a cosmic lighthouse. It's the spinning remnant of a star, and it sweeps a beam of radiation across space over and over again. From our perspective here on Earth, that beam flashes past us with such perfect timing you could literally set an atomic clock to it. Yeah, or so we thought. Because when astronomers pointed their telescopes at this one particular lighthouse, they found something was off. The clock wasn't just a little bit slow or fast. No, it was being warped and pulled in a way they had never, ever seen before. Okay, so this stuttering clock, it has a name. PSR B1620-26. It's what's called a millisecond pulsar, which means it spins on its axis every 11 milliseconds. Just let that sink in. And it lives inside this dense, ancient star cluster called Messier 4. It's right here that our cosmic detective story really kicks off. So what exactly is a pulsar? Well, imagine a massive star goes supernova, and what's left behind is its collapsed core. It's unbelievably dense, and it's spinning at an incredible speed. And it's that extreme regularity, that perfect timing, that makes them such powerful tools for astronomers. You see, any change in that timing tells you that some powerful gravitational force is messing with it nearby. And this right here gets to the heart of the puzzle. See, we already knew this pulsar wasn't alone. It had a buddy, a white dwarf star, and they were orbiting each other every 191 days. But even when you account for that predictable little dance, the signal was still wrong. The pulses were arriving a little bit early, then a little bit late, in this long, sweeping pattern that just made no sense for a simple two-star system. And we're not talking about a small error here. The scientists studying it called it anomalously large variations. I mean, the pulsar's rhythm was so messed up that the rate it was supposed to be slowly losing energy, it changed by a factor of 5 over just 11 years. It's like a spinning top was being pushed and pulled by some invisible hand. The data was practically screaming at them. Something else was out there. There had to be an unseen object, a gravitational ghost, causing all this bizarre behavior. But what in the world could it be? So this led to the leading theory, a really bold idea. What if this wasn't a two-body system at all? What if the pulsar and its white dwarf partner were being tugged on by the gravity of a third, unseen companion in a much, much wider orbit? Now, this kind of setup has a name. It's called a hierarchical triple system. And it sounds complex, but the idea is actually pretty elegant. You have a tight inner pair of objects, and then a third body orbits them from way out, treating the first two almost like they're a single object. This ballroom dance analogy is just perfect. So imagine two dancers spinning together really fast. That's our pulsar and white dwarf in their tight 191-day orbit. But while they're doing their own little spin, the pair of them as a single unit is also moving in this much grander, slower waltz around the entire ballroom. And who's leading that grand waltz? Well, it's the gravitational pull of that unseen partner standing way off in the distance. Okay, so they had a theory, but proving it, that wasn't going to be easy. It took a massive international effort, an observation campaign that stretched for more than a decade. It's a great reminder that science is often a game of patience and persistence. The whole quest kicked off way back in 1987 at Jodrell Bank in the UK. Pretty soon, other huge radio telescopes like the Green Bank Telescope and the Very Large Array jumped in to help. For 11 straight years, these teams just patiently collected data, timing pulse after pulse to piece together this incredible puzzle. And I want you to look at this number, because the precision they needed was just staggering. Over the course of their investigation, they timed the arrival of pulses from over 31 times billion individual rotations of that pulsar. It was that incredible level of detail that finally let them measure the tiny, long-term wobble being caused by that third body. So after 11 years and 31 billion rotations, the data was finally in. The moment of truth had arrived. It was time to unmask this gravitational ghost and find out what it really was. All the evidence was crystal clear. There was a third body. The models fit perfectly. But the huge question remained. What was it? Was it another star, a brown dwarf, or was it something else entirely? Well, the data delivered a stunning verdict. The object's mass was calculated to be about 0.01 solar masses. That's roughly 10 times the mass of Jupiter. Now, this puts it in a really fascinating gray area. It could either be a massive gas giant planet or a very small brown dwarf, what some people call a failed star. Either way, it was a substellar object, and its orbit is enormous. It sits about 35 astronomical units away from that inner pair of dead stars. To put that into perspective for you, that's about the same distance as Neptune is from our sun. It takes this thing around 100 years just to make one trip around. So let's just pause for a second and appreciate how wild this is. Astronomers found a planet orbiting not one, but two stars. And not just any stars, the dead remnants of stars. And because of where it is, it has to be incredibly ancient, maybe even one of the very first planets ever formed in the entire universe. But just when you think the story can't possibly get any weirder, there is one final mind-bending twist. Because it's not just about what they found, it's about where they found it. It's all about the bizarre, chaotic neighborhood this improbable family calls home. You see, this whole system is inside a globular cluster. I want you to imagine a stellar city, jammed packed with hundreds of thousands of ancient stars, all swarming around each other in this tight gravitational dance. It is one of the most chaotic, crowded, and violent places in the entire galaxy. And that is the real shocker here. Finding a planet in such a wide, delicate orbit, right in the chaotic heart of a globular cluster, that's like finding a perfect, pristine snowflake in the middle of a blast furnace. Every theory we have says it should have been ripped apart by a close encounter with another star billions of years ago. And yet, there it is. This single discovery completely shattered our expectations of where planets can form and where they can survive. So it leaves us with this incredible question. If a planet can exist in a place this ancient and this chaotic, where else in the universe might we be totally surprised to find them?